This lesson will be about writing the converse, inverse, and contrapositive of a conditional statement. A conditional statement is a statement written in the form P arrow Q. This means if P, then Q, where P is a hypothesis and Q is a conclusion. This problem asks to write the converse, inverse, and the contrapositive of the conditional statement. To write the converse, flip the conclusion and the hypothesis. So the converse of this conditional statement is, if tomorrow is Tuesday, then today is Monday. To write the inverse, put the word not in the conditional statement. So the inverse of this conditional statement will be, if today is not Monday, then tomorrow is not Tuesday. To write the contrapositive, write the inverse, and use the word not in the conditional statement. The contrapositive for this conditional statement will be, if tomorrow is not Tuesday, then today is not Monday. In this case, all three of the statements are true. This problem asks to write the converse, inverse, and contrapositive of the conditional statement. The converse of the conditional statement would be, if a triangle is isosceles, then it has two congruent sides. The inverse of the conditional statement would be, if a triangle not has two congruent sides, then it is not isosceles. The contrapositive to the conditional statement would be, if a triangle is not isosceles, then it not has two congruent sides. This problem also asks to write the converse, inverse, and the contrapositive of the conditional statement. The converse to the conditional statement would be, if the angle of a triangle is the largest, then the side of a triangle is the longest side. The inverse to the conditional statement would be, if the side of a triangle is not the longest side, then the angle opposite is not the largest. The contrapositive to the conditional statement would be, if the angle of a triangle is not the largest, then the side of a triangle is not the longest side. This problem also asks to write the converse, inverse, and the contrapositive of the conditional statement. The converse to the conditional statement would be, if the grade is at least a 90, then the grade is an A. The inverse to the conditional statement would be, if a grade is not an A, then the grade is not at least 90. The contrapositive to the conditional statement would be, if the grade is not at least a 90, then the grade is not an A. The next topic will be over properties of triangles. This lesson will be about the properties of a triangle's sides and angles. According to the triangle inequality theorem, the sum of any two sides of a triangle is greater than the third side. In reality, in order for three segments to make a triangle, the two smaller segments must add up and be greater than the third side. The problems below ask if the segments can make a triangle. To determine if they can make a triangle, start by adding the two smaller sides, in this case, 2 and 3. 2 plus 3 equals to 5. Because this is not greater than 5, then the three segments cannot make a triangle. Do the same for the second problem. Once again, add the two smaller segments and see if the sum is greater than the largest side. So 5 plus 6 is 11. 11 is greater than 8. So yes, this can make a triangle. The side relationships of a triangle determine the type of angles in a triangle. The type of angles in a triangle determine the classification of the triangle. If the sum of the square of the two shorter sides is equal to the square of the longest side, then the triangle will be a right triangle. But if the sum of the square of the two shorter sides is less than the square of the longest side, then the triangle will be an acute triangle. Lastly, if the sum of the square of the two shorter sides is greater than the square of the longest side, then the triangle will be an obtuse triangle. The triangle-angle sum theorem states, in Euclidean space, the sum of the interior angles is 180 degrees. The first problem asks to find the missing angle. To find the missing angle, set up an equation, then add the known sides, and subtract them from 180. In this case, add 45 and 71.6 to get 116.6, and subtract that from 180 to get 63.4. The second problem asks to solve for x. To solve for x, set up an equation. In this case, since the sum of the angles will be 180 degrees, in this problem the equation will be 35 plus x plus 20 plus 4x plus 10. Next, combine like terms. So add 35, 20, and 10 together, and add x and 4x together to get 5x plus 65 equals to 180. Next, subtract 65 from both sides to get 5x equals to 115. Then finish solving the equation by dividing by 5 to get x equals to 23. The exterior angle of a triangle theorem states that, in Euclidean space, the exterior angles of a triangle form linear pairs with the angle interior to it. Additionally, the exterior angles of a triangle are equal to the sum of the two remote interior angles. The problem below asks to find the value of each angle. This means that this is a multi-step problem, where you will have to first find the value of x, and then use the value of x to find the measure of each angle. By the exterior angle theorem, 140 is equal to the two remote interior angles, x and 4x, so 4x plus x equals to 140. This becomes 5x equals to 140. Finish solving the equation by dividing 5 to both sides to get x equals to 28. Now that x is known, it can be substituted into 4x and x to find the missing angles. The first angle is 40 degrees because it forms a linear pair to the exterior angle. The angle where x is at is 28 because x equals to 28. The angle where 4x is at is 4 times 28 equals to 112. This lesson will be about how to find the points of concurrency in triangles. There are 4 points of concurrency. They are the circumcenter, incenter, centroid, and orthocenter. The circumcenter is the point of concurrency formed by the perpendicular bisectors of each side. The incenter is the point of concurrency formed by the angle bisectors of each vertex. The centroid is the point of concurrency formed by the medians of a triangle. And the orthocenter is the point of concurrency formed by the altitudes of a triangle. To find the circumcenter of a triangle, find the perpendicular bisectors of each side. To find the perpendicular bisectors of each side, make each side the radius of 2 circles and draw a line where each pair of circles intersect. Once all 3 perpendicular bisectors have been constructed, plot a point where they all intersect, and that will be the circumcenter. Next, draw a circle using the circumcenter as the center and any of the vertexes of the triangle as the endpoint of the radius. The next construction will be finding the centroid. To find the centroid, you will need to find the midpoints of each side of the triangle. To find the midpoint, you can find the perpendicular bisector of each side. Once a perpendicular bisector is constructed, plot points where the line intersects its side. Once all midpoints have been found, draw a segment from each midpoint to the vertex opposite to it. This will be called a median. After drawing each median, plot a point where they all intersect, and this will be the centroid. The third construction will be the incenter. The incenter will be the intersection of all angle bisectors. To find the angle bisector, draw arcs or circles. Then use the arcs to create new arcs that have the same length as the distance of the intersection of the arc to the vertex. Then draw a ray from a vertex to the intersections of two new arcs. Repeat this process for the other two angles. Once all angle bisectors have been constructed, plot a point where they all intersect, and that will be the incenter. Lastly, draw a circle using the incenter as its center and intersection of the angle bisector and the side as the radius. The fourth construction will be the orthocenter, which is the intersection of all altitudes, which are perpendicular segments from the vertex to the side opposite of the vertex. To find the altitude, start by constructing an arc from the vertex to the side opposite. Then plot points at the intersections of the arc and the opposite segment. Next, construct a perpendicular bisector to the points that intersect the arc and the opposite side. The line of the perpendicular bisector will run through the two arc intersections and the vertex. Repeat the process for the other vertexes. After all of the altitudes have been constructed, plot a point where all the altitudes intersect. The next topic will cover proofs and properties of parallel lines. This lesson will be about postulates. The angle addition postulate states, if point D lies in the interior of angle ABC, then the measure of angle ABD plus the measure of angle DBC equals to the measure of angle ABC. The linear pair postulate states, if two angles form a linear pair, then the angles are supplementary. The segment addition postulate states, if point B is on segment AC and between points A and C, then AB plus BC equals AC, or the measure of segment AB plus the measure of segment BC equals measure of segment AC. The addition property and subtraction property are both used when solving algebraic equations. The reflexive property states if it's a real numbers, then A equals A. The substitution property, if A and B are real numbers and A equals B, It can be substituted for b. Substitution is used in many ways. For instance, when you know the measure of an angle, you substitute the angle measure rather than write down the angle name. The transitive property states if a, b, and c are real numbers and a equals b, and b equals c, then a equals c. Some examples of the postulates at work are shown in figure below. When using angle measures, if the measure of angle 1 is equal to the measure of angle 3, then adding the measure of angle 2 to both angles would also give the same angle measure. This is the addition property of equality at work. The same can be done for segment measures. The figure shows if the measure of segment AB equals to the measure of CD, then adding the measure of BC to both would remain equal. The same can be used measured distances. The first problem asks to use the subtraction property of equality to write a statement. Since this is about using subtraction, it is best to state if two angles are equal, then taking away the same piece of them will be equal. Start with if angle AEC is equal to angle BED, then taking away the middle angle. BC will show angle AEC equals to angle BED. The second problem asks to use the reflexive property to write a statement. The reflexive property would simply state that angle A equals to angle A. The third problem asks to use the substitution property to write a statement. The statement would say that if the measure of angle A equals to 90 degrees and the measure of angle B equals to 90 degrees, then the measure of angle A equals to the measure of angle B. The fourth problem asks to use the transitive property to write a statement. The statement would say that if the measure of angle A to the measure of angle B, and if the measure of angle B equals to the measure of angle C, then the measure of angle A equals to angle C. This lesson will be over flowcharts and two-column proofs. This problem asks to complete the flow chart of the right angle congruence postulate. When writing a proof, start with what is given. Angle BCD is a right angle because it is given. Because angle BCD is a right angle, then it equals to 90 degrees because that is the definition of a right angle. Because angle ACD and angle BCD equal to the same thing, 90 degrees, they are equal to each other by the transitive property. Because both angles equal to each other, then they are congruent to each other by the definition of congruent angles. Two-column proofs and flowchart proofs work the same. You can rewrite a flow chart in a two-column format and vice versa. You may notice that the top part in a flow chart is the statement section of a two-part proof, and the bottom part of a flow chart is the reason part of a two-column proof. This section will cover how to find unknown angle measures. Before getting to finding unknown measures, you will need to be able to solve algebraic equations. For equation A, start with adding like terms. So 45,000 plus 2,500 equals to 47,500. Next, subtract 54,000 from both sides to isolate the variable. This will become negative 6,500 equals to 1,500x. And finish the problem with dividing 1,500 to both sides, making x equal to negative 4 1/3. For equation B, start with isolating the variable. So subtract 2.50t from both sides. Then subtract 225 from both sides to get 125 equals to 0.5t. Finish the problem off by dividing both sides by 0.5 to get t equals to 250. For equation C, start with isolating the variables, so subtract 2x to both sides and add 4x to both sides to make the equation 9 equals to 3x minus 12. Next, add 12 to both sides to make the equation 21 equals to 3x. Finish the problem by dividing 3 to both sides to get x equals to 7. Once you have proved a theorem, you know that it is true in all instances. You can apply these theorems to determine unknown geometric measures. The right angle congruence postulate states, all right angles are congruent. The congruent supplement theorem states, if two angles are supplements of the same angle of congruent angles, then the angles are congruent. The vertical angle theorem states, vertical angles are congruent. This problem asks to find each angle measure. The figure shows a vertical pair of angles. Vertical pairs equal to each other. Because the angles equal to each other, an equation can be written to solve for x and then substituted to find the angle measures. The equation will be x plus 94 equals to 4x plus 25. Subtract 25 from both sides, and then subtract x from both sides to get 69 equals to 3x. Finish the problem by dividing both sides by 3 to get 23 equals to x. Next, substitute the value of x for one of the angles. For instance, using x plus 94 would become 23 plus 94, which is 117. Next, label the angles. Both will be 117 because they are vertical angles. To find the rest of the angles, use the linear pair postulate to state that the missing angle plus 117 equals to 180. Therefore, the missing angles are 63 degrees. And finish labeling the figure. Lastly, write the angle measures next to their name. This problem asks to find the missing angle measures. The figure shows a linear pair of angles. This means that you can say that the sum of both unknown angles is equal to 180 degrees. Therefore, 3x plus 4 plus x plus 24 equals to 180. To solve the equation, start with combining like terms. So add 3x with x, and add 4 with 24 to make the equation 4x plus 28 equals to 180 degrees. Then subtract 28 to both sides to get 4x equals to 152, and finish by dividing both sides by 4 to get x equals to 38. Once the value of x becomes known, use substitution to find the values of the missing angles. So by substitution, 3x plus 4 becomes 3 times 38 plus 4, which equals to 118. Next, label the congruent vertical angle. Then use substitution to turn x plus 24 into 38 plus 24 to state the other missing angles are equal to 62. Finish labeling the diagram. Lastly, answer the question by writing the angle measures next to their names. The next lesson will be about theorems about parallelism. The corresponding angles theorem states, if two parallel lines are intersected by a transversal, then corresponding angles are congruent. So, for instance, angle 1 and angle 5 are corresponding angles because they are at the top left of their line. Angle 2 and angle 6 are corresponding angles because they are at the top right of their line. Angle 3 and angle 7 are corresponding angles because they are at the bottom left of their line. Angle 4 and angle 8 are corresponding angles because they are at the bottom right of their line. If the angles so formed are adjacent to each other after the intersection of the two lines, the angles are said to be linear. If two angles form a linear pair, the angles are supplementary, whose measures add up to 180 degrees. Hence, a linear pair of angles always add up to 180 degrees. Angle 1 and angle 2 are a linear pair. Angle 1 and angle 3 are a linear pair. Angle 2 and angle 4 are a linear pair. Angle 2 and angle 4 are a linear pair. Angle 5 and angle 6 are a linear pair. Angle 5 and angle 7 are a linear pair. Angle 6 and angle 8 are a linear pair. Angle 7 and angle 8 are a linear pair. The perpendicular/parallel line theorem states, if two lines are perpendicular to the same line, then the two lines are parallel to each other. If all angles in both lines are right angles or equal to 90 degrees, then both lines are parallel. The alternate interior angles theorem states, if two parallel lines are intersected by a transversal, then the alternate interior angles are congruent. According to the figure, angle 3 and angle 6 are alternate interior angles. Angle 4 and angle 5 are also alternate interior angles. The same side interior angles theorem states, if two parallel lines are intersected by a transversal, then the interior angles on the same side of the transversal are supplementary. Angles 4 and 6 are same-side interior angles. Additionally, angles 3 and 5 are same-side interior angles. This problem asks to find all the missing angle measures given that the measure of angle 1 is 70 degrees. Since angle 2 forms a linear pair with angle 1, angle 2 will be 180 minus 70, therefore 110 degrees. Angle 3 also forms a linear pair with angle 1, therefore angle 3 also is 110 degrees. Angle 4 is a vertical pair with angle 1, so it is 70 degrees. Angle 5 is a corresponding angle to angle 1, so it is 70 degrees. Angle 6 and 7 form linear pairs with angle 5, so they are 110 degrees. Lastly, angle 8 is a vertical pair with angle 5, so angle 8 is 70 degrees. The alternate exterior angles theorem states, if two parallel lines are intersected by a transversal, then the alternate exterior angles are congruent. Using the figure, angles 1 and 8 are alternate exterior angles. Additionally, angles 2 and 7 are alternate exterior angles. The same-side exterior angles theorem states, if two parallel lines are intersected by a transversal, then the same-side exterior angles are supplementary. In the figure, angles 1 and 7 are same-side exterior angles. Additionally, angles 2 and 8 are same-side exterior angles. This problem asks to determine the theorem that matches to each if-then statement. Statement A states, if line P is parallel to line R, then angle 2 is congruent to angle 7. This is true because of the alternate exterior angles theorem. Statement B states, if line P is parallel to line R, then angle 4 is congruent to angle 5. This is true because of the alternate interior angles theorem. Statement C states, if angle 3 is congruent to angle 6, then line P is parallel to line R. This is true because of the alternate interior angles theorem. Statement D states, if line P is parallel to line R, then angle 1 is congruent to angle 5. This is true because of the corresponding angles theorem. Statement E states, if line P is parallel to line R, then angle 4 plus angle 6 equals to 180 degrees. This is true because of the same side interior angles theorem. Statement F states, if line P is parallel to line R, then angle 1 plus angle 7 equals to 180 degrees. This is true because of the same side exterior angles theorem. Statement G states, if angle 3 plus angle 5 equals to 180 degrees, then line P is parallel to line R. This is true because of the same side interior angles theorem. The next topic will be about angles of polygons, isosceles triangles, and special right triangles. This lesson will be about the interior and exterior angles of triangles and polygons. Recall that the triangle sum theorem states the sum of the measures of the interior angles of triangle is equal to 180 degrees. For the first triangle, to find the missing angle x, write the equation 23 plus 124 plus x equals to 180. To solve for x, add like terms, so 23 plus 124 to get 147 plus x equals to 180. Then subtract 147 from both sides to get x equals to 33 degrees. For the second triangle, to find the missing angle, write the equation 50 plus 95 plus x equals to 180. To solve for x, add like terms, so 50 plus 95 to get 145 plus x equals to 180. Then subtract 145 from both sides to get x equals to 35 degrees. For the last triangle, to find the missing angle, write the equation 90 plus 20 plus y equals to 180. To solve for y, add like terms, so 90 plus 52 to get 142 plus y equals to 180. Then subtract 142 from both sides to get y equals to 38 degrees. Recall that the exterior angle theorem states the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. The problem below asks to solve for x. To solve for x, use the exterior angle theorem to write the equation x plus x equals to 152. To solve for x, combine like terms, so x plus x to get 2x equals to 152, and then divide both sides by 2 to get x equals to 76. The problem's asked to use the exterior angle theorem to solve for x. For the first triangle, to solve for x, write the equation 120 equals to 3x plus 2x. To solve for x, combine like terms, so add 3x and 2x to get 120 equals to 5x. Then divide both sides by 5 to get 24 equals to x. For the second triangle, to solve for x, write the equation. 126 equals to x plus 2, x plus 6. Next, combine like terms. So add x plus 2x to get 126 equals to 3x plus 6. Then, subtract 6 from both sides to get 120 equals to 3x. Finish by dividing both sides by 3 to get 40 equals to x. Below are regular polygons. When drawing diagonals, triangles will be made. This is key in determining the angle relationships in regular polygons. When drawing diagonals in polygons, triangles are formed. The number of triangles is equal to the number of sides in a polygon minus 2. In a three-sided polygon or a triangle, 0 diagonals can be drawn. There is one triangle, and the sum of the measures of the interior angles is 180 degrees. In a four-sided polygon, one diagonal can be drawn. There are two triangles, and the sum of the measures of the interior angles is 360 degrees. In a five-sided polygon, also known as a pentagon, two diagonals can be drawn. There are three triangles, and the sum of the measures of the interior angles is 540 degrees. In a six-sided polygon, also known as a hexagon, three diagonals can be drawn. There are four triangles, and the sum of the measures of the interior angles is 720 degrees. In a seven-sided polygon, also known as a heptagon, for diagonals can be drawn. There are five triangles, and the sum of the measures of the interior angles is 900 degrees. In an eight-sided polygon, also known as an octagon, five diagonals can be drawn. There are six triangles, and the sum of the measures of the interior angles is 1,080 degrees. In a nine-sided polygon, also known as a nonagon, six diagonals can be drawn. There are seven triangles, and the sum of the measures of the interior angles is 1,260 degrees. In a 16-sided polygon, 13 diagonals can be drawn. There are 14 triangles, and the sum of the measures of the interior angles is 2,520 degrees. The formula to determine the sum of the measure of the interior angles of an n-gon is n minus 2 times 180, where n is the number of sides a polygon has. The formula to determine the measure of each individual interior angle of an n-gon is n minus 2 times 180 divided by n. This lesson will be about the exterior angles of polygons. This problem asks to write a formula for the sum of the measures of the exterior angles of a polygon. The figure shows a triangle. In each triangle, there are three exterior angles. Each exterior angle forms a linear pair of the angle interior to it. Since there are three linear pairs, then this is 180 times 3, which is 540. However, the interior angle sum is 180, meaning to get the exterior angle sum, subtract 180 from 540 to get 360 degrees. Exterior angles form linear pairs with interior angles. You can use the fact that every polygon will have the same number of linear pairs as it does sides to find the sum of the measures of the linear pairs, and take away the sum of the measures of the interior angles to determine the sum of the measures of the exterior angles, which brings us to the table. In a three-sided polygon, also known as a triangle, there are three linear pairs. The sum of the measures of the linear pairs is 540 degrees. The sum of the measures of the interior angles is 180 degrees. The sum of the measures of the exterior angles is 360 degrees. In a four-sided polygon, there are four linear pairs. The sum of the measures of the linear pairs is 720 degrees. The sum of the measures of the interior angles is 360 degrees. The sum of the measures of the exterior angles is 360 degrees. In a five-sided polygon, also known as a pentagon, there are five linear pairs. The sum of the measures of the linear pairs is 900 degrees. The sum of the measures of the interior angles is 540 degrees. The sum of the measures of the exterior angles is 360 degrees. In a six-sided polygon, also known as a hexagon, there are six linear pairs. The sum of the measures of the linear pairs is 1,080 degrees. The sum of the measures of the interior angles is 720 degrees. The sum of the measures of the exterior angles is 360 degrees. In a seven-sided polygon, also known as a heptagon, there are seven linear pairs. The sum of the measures of the linear pairs is 1,260 degrees. The sum of the measures of the interior angles is 900 degrees. The sum of the measures of the exterior angles is 360 degrees. In a 15-sided polygon, there are 15 linear pairs. The sum of the measures of the linear pairs is 2,700 degrees. The sum of the measures of the interior angles is 2,340 degrees. The sum of the measures of the exterior angles is 360 degrees. The shortcut formula to find the exterior angle of a regular polygon is 360 divided by n, where n is the number of sides the polygon has. This problem asks to determine the value of each exterior angle of a given polygon. Recall that if the sum of the exterior angles in a polygon is always 360, then each interior angle will be 360 divided by the number of sides. For part A, an equilateral triangle will have three sides. So this will be 360 divided by 3, which equals to 120 degrees. For part B, a square will have four sides. So this will be 360 divided by 4, which equals to 90 degrees. For part C, a regular pentagon will have five sides. So this will be 360 divided by 5, which equals to 72 degrees. For part D, a regular hexagon will have six sides. So this will be 360 divided by 6, which equals to 60 degrees. This problem asks to find the value of x. To find a x, you will need to find the interior angles of the pentagon, then find the exterior angle of the pentagon, and then use the triangle angle sum theorem to find the missing angle. Since PENTA is a regular pentagon, you can use the formula n minus 2 times 180 divided by n to find the value of each angle. Using substitution, this will be 5 minus 2 times 180 divided by 5, which equals to 108. This means that each interior angle is 108 degrees. The pentagon's interior angles 4, a linear pair with interior angles of a triangle. Because both angles are linear pairs, then an equation can be used to represent the problem. Using the linear pair postulate, the equation will be 108 plus x equals to 180, so x will equal to 72 degrees. By the triangle angle sum theorem, the interior angles will add to 180 degrees. The equation will be 72 plus x equals to 180. After adding like terms, this will be 144 plus x equals to 180, and then x equals to 36, so the value of x is 36 degrees. This lesson will be over isosceles triangles. The perpendicular bisector theorem states, points on a perpendicular bisector of a line segment are equidistant from the segment's endpoints. The perpendicular bisector converse theorem states, if a point is equidistant from the endpoints of a line segment, then the point lies on the perpendicular bisector of the segment. The hypotenuse angle HA congruence theorem states, if a hypotenuse and an acute angle of one right triangle are congruent to the hypotenuse and an acute angle of another right triangle, then the two triangles are congruent. The angle side AS congruence theorem states, if two angles and the non-included side of one triangle are congruent to two angles and the non-included side of another triangle, then the two triangles are congruent. Isosceles triangle base angles theorem states, if two sides of a triangle are congruent, then the angles opposite these sides are congruent. The problems below ask to determine the value of x in each of the isosceles triangles. Each triangle has a perpendicular bisector to show that it is an isosceles triangle. The first triangle shows a triangle with a perpendicular bisector and a 30-degree angle. To solve for x, you need to find the first missing angle. The missing angle is 60 degrees because 90 plus 30 plus 60 equals to 180. Now set up an equation to state both base angles are equal. So, 2x minus 13 equals to 60. Add 13 to both sides to get 2x equals to 73. Then divide to get x equals to 36.5. The second triangle has a perpendicular bisector and shows that the opposite sides are congruent, thus making an isosceles triangle. This means that each side of the left proportion of the triangle is 3 inches, making the length of the left side 6 inches. To find x, set up an equation. 5x minus 10 equals to 6. After adding 10 to both sides to get 5x equals to 16. Divide by 5 to both sides to get x equals to 3.2. The third triangle has a perpendicular bisector and shows that the opposite sides are congruent, thus making an isosceles triangle. Because a triangle has a perpendicular bisector, for x is equal to 32. To find x, divide 32 by 4 to get x equals to 8. This lesson will be over special right triangles. "45 degrees, 90 degrees triangle theorem states, the length of the hypotenuse in a 45 degree 90 degree triangle is square root 2 times the length of a leg. A 45, 90 degree right triangle is isosceles because it has two congruent base angles. Then the sides are also congruent. This means that if both legs have a length of x, then when solving for the hypotenuse using Pythagorean theorem, you'll end up with x times the square root of 2 for the length of the hypotenuse. Here's a quick proof. By Pythagorean theorem, c squared equals to x squared plus x squared. After adding like terms, this will be c squared equals to 2x squared. To solve for c, take the square root of both sides, which gets the square root of 2x squared, which is x times the square root of 2. 30 degrees, 60 degrees, 90 degrees triangle theorem states the length of the hypotenuse in a 30 degrees, 60 degrees, 90 degrees triangle is 2 times the length of the shorter leg, and the length of the longer leg is square root 3 times the length of the shorter leg. To get a 30, 60, 90 degree right triangle, an equilateral triangle must have a perpendicular bisector to bisect the 60 degree angle. By doing so, one leg will be half the radius and the hypotenuse will be the radius of a circle. This creates the x and 2x relationship between the shorter leg and the hypotenuse. To prove that the longer leg is the square root of 3 times the length of the shorter leg, you use Pythagorean theorem. By Pythagorean theorem, 2x squared equals to x squared plus b squared. Using the power of product rule of exponents, this becomes 4x squared equals to x squared plus b squared. When subtracting x squared to both sides, this becomes 3x squared equals to b squared. By taking the square root of both sides, this will become the square root of 3x squared equals to b, then x times the square root of 3, when fully simplifying the square root. The problems below ask to find the missing sides of the special right triangles. The first triangle is a 30, 60, 90 right triangle, meaning that the ratios of the legs will be x times the square root of 3 and 2x. 5 units is a short leg, so it would be x as the ratio. X is the long leg, so this will be x times the square root of 3, and y is the hypotenuse, so it will be 2x. This means the long leg will be 5 times the square root of 3, and y will be 2 times 5, which is 10. The second triangle also is a 30, 60, 90 right triangle, meaning that the ratios of the legs will be x times the square root of 3 and 2x. X is the short leg, so it would be x as the ratio. 7 times the square root of 3 is the long leg, so this will be x times the square root of 3, and y is the hypotenuse, so it will be 2x. Since 7 times the square root of 3 is equal to x times the square root of 3, this is the starting place of the problem. Using 7 times the square root of 3 is equal to x times the square root of 3, and dividing by the square root of 3 gets the 7 equals to x. Since y is equal to 2x, then y equals to 2 times 7, which is 14. The third triangle is a 45, 45, 90 degree right triangle, so we'll have side ratios of x times the square root of 2. Sides 9 units, and y will have a ratio of x, and side x will have a ratio of x times the square root of 2. Side y will be equal to 9 units, and side x will be 9 times the square root of 3. The fourth triangle is a 45, 45, 90 degree right triangle, so we'll have side ratios of x times the square root of 2. Sides x and y will have side length ratios of x, and side 12 times square root 2 will have a side ratio of x times the square root of 2. To find x, set up the equation 12 times the square root of 2 equals to x times the square root of 2. Then divide both sides by the square root of 2 to get x equals to 12. Now that x is known, That means side x is 12, and because side x equals to side y, then side y equals to 12. The two problems below are problems that ask to find the missing sides, but the denominators will have to be rationalized. The left triangle is a 30, 60, 90 right triangle, meaning that the ratios of the legs will be x times the square root of 3 and 2x. Side V will be x. Side 6 meters will be x times the square root of 3. Side W will be 2x. Start with solving for x. So write the equation. 6 equals to x times the square root of 3. To solve for x, divide both sides by the square root of 3. To rationalize the denominator, multiply the numerator and the denominator of the fraction by the square root of 3. This will then become x equals to 6 times the square root of 3 divided by 3. The right triangle is a 45, 45, 90-degree right triangle. So we'll have side ratios of x times the square root of 2. Sides x and y will have side ratios of x, and side 11 units will have side ratio of x times the square root of 2. Start with solving for x. So 11 equals to x times the square root of 2. Then divide both sides by the square root of 2. This becomes 11 over the square of 2 equals to x. To rationalize the denominator, multiply the numerator and denominator by the square root of 2. To get 11 times the square root of 2 divided by 2 equals to x and y, because x and y are equal to each other. The two problems below are problems that ask to find the missing sides, but the square roots will have to be extracted. The left triangle is a 30, 60, 90 right triangle, meaning that the ratios of the legs will be x times the square root of 3 and 2x. Side P will be x. Side Q will be x times the square root of 3. Side 2 times the square root of 21 will be 2x. Start with solving for x. 2x equals to 2 times the square root of 21. Divide both sides by 2 to get x equals to the square root of 21. This means P is the square root of 21. Next, substitute x in for Q's ratio. The square root of 21 times the square root of 3 equals to the square root of 63. This equals the square root of 3 times 7, which means you can extract a pair of 3's. This will then become 3 times the square root of 7. Therefore, Q equals to 3 times the square root of 7. The right triangle is a 30, 60, 90 right triangle, meaning that the ratios of the legs will be x times the square root of 3 and 2x. Side square root of 6 units will be x. Side x will be x times the square root of 3. Side y will be 2x. X will be the square root of 6 times the square root of 3. This will be equal to the square root of 18, which square root of 3 times 2. One pair of 3's can be extracted, making the expression become 3 times the square root of 2. Since y equals to 2x, y will be equal to 2 times the square root of 6. Therefore, y equals to 2 times the square root of 6. This topic will go over angles and circles. This lesson will be about the inscribed angle theorem. Recall that an inscribed angle is an angle where all 3 vertices lay on the circumference of the circle. There are 3 cases that this may occur. Case 1. TH angle is inscribed in such a way that the center point lies on one side of the inscribed angle. Case 2. TH angle is inscribed in such a way that the center point lies on the interior of the inscribed angle. Case 3. TH angle is inscribed in such a way that the center point lies on the exterior of the inscribed angle. The inscribed angle theorem states, the measure of an inscribed angle is half the measure of its intercepted arc. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. An intercepted arc is a portion of circumference of a circle located on the interior of the angle whose endpoints lie on the sides of an angle. This problem's asked to make a proof that angle MPT is 1/2 of angle MOT, given that O lies on a diameter, and angle MPT equals x. Start with label angle MPT as x, and constructing segment OT. Segment OT is congruent to segment OP, because they are both the radius of the circle. Because segments OT, OP, and PT form a triangle, and segments OT and OP are congruent, then this is an isosceles triangle. And because this is an isosceles triangle, then angle PTO will equal to x because the base angles in an isosceles triangle is congruent. The exterior angle of a triangle is equal to the sum of the two remote interior angles. So x plus x is 2x. Angle MOT is the exterior angle of a triangle, so it is equal to 2x. As of right now, angle MOT equals to 2 of angle MPT. But by multiplying both sides of the equation states that 1/2 of angle MOT equals to MPT. This can also be read as angle MPT equals to 1/2 of angle MOT. The multiplication property of equality was used when multiplying both sides of the equation by 1/2. The problems below ask to find the missing angle. The inscribed angle is 1/2 the central angle, or the central angle is 2 times the inscribed angle. In the left circle, x is the central angle. 80 degrees is an inscribed angle. Using the inscribed angle theorem, 80 degrees is 1/2 of x. To solve this equation, multiply both sides by 2 to get 160 equals to x. Recall, the central angle is equal to the minor arc it intercepts. 70 degrees is the minor arc. COB would be the central angle. Angle CAB is an inscribed angle. By the inscribed angle theorem, 70 degrees is 2 times x. So 70 equals to 2x, solved by dividing by 2 to both sides to get x equals 35. The inscribed right triangle diameter theorem states, if a triangle is inscribed in a circle such that one side of the triangle is the diameter of the circle, then the triangle is a right triangle. The inscribed quadrilateral opposite angles theorem states, if a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. This lesson will be about the interior and exterior angles of a circle. If a circle has 2 intersecting segments inside the circle, then there are interior angles. To find and measure the interior angles, add the arcs and divide by 2. If a circle has 2 intersecting rays outside the circle, Then there are exterior angles. To find the measure of the exterior angle, subtract the arcs and divide by 2. The interior angles of circle theorem states, if an angle is formed by two intersecting chords or secant of a circle, such that the vertex of the angle is in the interior of the circle, then the measure of the angle is half of the sum of the measures of the arcs intercepted by the angle and its vertical angle. The exterior angles of circle theorem states, if an angle is formed by two intersecting chords or secants of a circle, such that the vertex of the angle is in the exterior of the circle, then the measure of the angle is half of the difference of the measures of the arcs intercepted by the angle. The problems below ask to solve problems using the exterior angles of an arc theorem. The first circle asks to determine the measure of arc FI, given that the measure of angle K is 20 degrees and the measure of arc GJ is 80 degrees. To find the measure arc FI, use the exterior angle of a circle theorem to state that 1/2 of arc FI minus arc GJ equals to angle K. This will be written as 1/2 x minus 80 equals to 20. To solve for x, start with multiplying 2 to both sides of the equation to get x minus 80 equals to 40. Next, add 80 to both sides of the equation to get x equals to 120. Therefore, the measure of arc FJ is 120 degrees. The second problem asks to determine the measure of angle x, given that the measure arc VW is 40 degrees and the measure of arc TU is 85 degrees. In this case, angle x is the exterior angle to the smaller circle. So, by the exterior angle of a circle theorem, 1/2 of 85 minus 40 equals to x. To solve for x, start by subtracting 85 minus 40. To get 1/2 of 45 is equal to x. Next, multiply 45 by 1/2, or divide 45 by 2, to get 22.5 equals to angle x. The third problem asks to find the measure of angle D, given the measure of arc ZXC equals to 120 degrees, and the measure of arc CB equals to 30 degrees. Because angle D is an exterior angle, you need to find 1/2 of arc ZAB and arc CB. However, measure of arc ZAB is not given, meaning you need to find its measure first. To find the measure of arc ZAB, first you need to understand that a circle is 360 degrees, and that arc ZAB is the rest of the circle. This means the arc ZAB equals to 360 minus 120 and 30. 360 minus 120 and 30 is 210. So arc ZAB equals to 210 degrees. Next, by the exterior angle of a circle theorem, 1/2 of 210 minus 30 equals to angle D. Next, subtract 30 from 210 to get 1/2 of 180 equals to angle D. Then multiply 180 by 1/2 or divide by 2 to get 90 degrees equals to angle D. The tangent to a circle theorem states, a line drawn tangent to a circle is perpendicular to a radius of the circle drawn to the point of tangency. The problem on the left asks to find the measure of arc RT, given that measure of arc FG equals to 86 degrees, and the measure of arc HP is 21 degrees. Since angle FWG is an inscribed angle with respect to the bigger circle and an exterior angle to the smaller circle, you can start by using the inscribed angle of a circle theorem to state that angle FWG is 1/2 of 86. This means that angle FWG is 43 degrees. Now, using the exterior angle of the circle theorem states that angle FWG equals to 1/2 arc RT minus arc HP. By substitution, this will be 43 equals to 1/2 of arc RT minus 21. To solve for arc RT, start with multiplying 2 to both sides to get 86 equals to arc RT minus 21. Then add 21 to both sides of the equation to get 107 equals to arc RT. The second problem asks to determine the measure of arc CD, given the measure of arc AB equals to 88 degrees and arc AD equals to 80 degrees. To find arc CD, use the interior angle of the circle theorem to state angle CED equals to 1/2 of CD plus BA. However, at the current moment, angle CED is also unknown, so that becomes a starting place. Since angle CED and AED form a linear pair, the measure of angle CED can be found by stating angle CED plus angle AED equals to 180. By substitution, angle CED plus 80 equals to 180. Subtract 80 from both sides to get angle CED equals to 100. Next, use the interior angle of a circle theorem to state angle CED equals to 1/2 of arc CD plus arc BA. By substitution, this will be 100 equals to 1/2 arc CD plus 88. So solve for arc CD, multiply both sides by 2 to get 200 equals to arc CD plus 88. Finish solving the equation by subtracting 88 to both sides to get 112 equals to CD. This is the end of the video. Thanks for watching.